Okay, so I'm going to start off with the example questions that people had, examples that people had questions about. I'm going to start with example 10.9 because there are several people had questions about 10.9. It says assume a magnetic pole with a face is square that's 3 centimeters on a side. So it's like the end of the face of the magnet, like here was that magnet that I used in the problem, and so we're talking about the face of that. And that's the example magnet I used in the demonstration. And then it says find the force on the conductor, so that'd be the equivalent like the push on that green wire that I had. If the wire has a current of 2 amps and the conductor is perpendicular to the field and the field has a flux density of 0.35 teslas. So the formula for this is force equals, give it in here, magnetic field times the current times the length. So magnetic field times current times length. So that part's pretty straight up. I have magnetic field is 0.35 teslas. The current is 2 amps. And the length is 3 centimeters. So that would be equal to 0.35 times 6. 2 times 3 is 6. So that's 1/3 of 6. That's going to be about 2. Okay. Except I've screwed something up here because 3 centimeters is 0.03 meters. So then that's 0.06. Right. So multiply this out, and then I get 0.35 times 0.06, 0.021. I must be doing something wrong. The book is giving me 0.21. Let's see. 0.35, 2, and 0.03. 0.35 times 2 times 0.03. 0.35 times 2 times 0.03. 0.021. Could the book have a typo here? If there's something I'm missing, somebody email me. That seems to me like there's 3 centimeters, 2 amps, and 0.35 teslas, and I've got all those. 0.35 times 2 times 0.03. My answer that I'm getting is 0.021 newtons. The book has 0.21 newtons, so I'm not sure. Usually I've got some students to check my numbers, make sure I didn't do my math wrong, but I'm not seeing, if I'm making a calculation error here, I'm not seeing what it is. Then it says, what is the direction of the force if the field is directed up along the x-axis, along the y-axis, so up. So this is the magnetic field. This is the magnet right here. Okay? So this is the magnet. Face of the magnet is up, and here is the wire. The wire is hanging into the board like this. Okay, so the wire is going like that into the board. It says if the field is directed up along the y-axis and the current is directed in. So you do the right-hand rule for this. You have the current goes in the direction of the index finger. The magnetic field goes in the direction of the middle finger. Okay, I can remember that because the I is the index finger, I index, and the magnetic field is B, and your middle finger is the bird finger. Okay, so and then the force is in the direction of your thumb. So that's how you remember. Okay, so I got current this way, field up, force that way. So the force would be like thusly. So the far we get that the force is to the right. All right. So I'm going to take a pause and check that out and make sure I've done everything right.